So need to turn off transcription. Okay, and we will start. So today's agenda, we are talking about MVC, Model View Controller. We will talk a little bit about Flux, Redux, and React Redux. We will take a look at the few examples there. So let's get started with Model View Controller. Model View Controller is an architectural pattern used for development the user interfaces. And it divides the application into three different logical components: the model, the view, and the controller. It is the first introduced in 1976 in a Smalltalk programming language. In Model View Controller, each component is built to handle specific development aspect of an application. It is one of the most used web development frameworks to create scalable projects. So the Model View Controller architecture contains the three components. There are model. Here, it is responsible for maintaining the behavior and data of the application. The view, it is used to display the model in a user interface. And the controller. It acts as an interface between the model and the view component. It takes user input, manipulates the data model, and causes the view to updates. In reality, in ideal world, we expect that for each component we have each model, each MVC, Model View Controller, but unfortunately our world is not ideal. So that's why we have a little bit more complicated structure, and we might see that sometimes different components have connections between each other in different ways. So let's talk about Flux. According to the official site, Flux is the application architecture that Facebook used for building client-side web applications. It is an alternative to Model View Controller architecture and other software design patterns for managing how data flows in a React application. It is the backbone of all React applications. It isn't a library nor a framework. Its component React is a view. It complements React as Vue and flows the concept of unidirectional data flow model. Flux architecture has three major roles in dealing with data. This is a dispatcher, stores, views means React components. Action, it's like a creator, helper method, create an application from method parameters, assign it a type, and then provide the dispatcher. Dispatcher acts as a central hub. It sends every action to all stores via callbacks that have registered with it. It updates, then store updates themselves in response to an action. to an action amid the changes event to alter the controller view. Then controller view listeners, the controller view listeners for change events retrieve new data from the store and provide the new data to their descendants in a companion tree. So what else? You know, like if we try to compare model view controller with Flux, we might see that model view controller model view controller appears in 1976, but for Flux, just a few years ago was introduced in a few years ago by Facebook, right? So a model view controller supported BI directional data flow model. In this, data binding is the key, and model view controller in synchronous controller handle everything logic I'm talking about, and it is hard to debug. But Flux, because he using more modern approaches, is supported unidirectional data flow model. It is events or actions are the keys. It's asynchronous. Here is a store bundled all logic. It is easy to debug because it has common initiation point dispatcher. It's easy to understand. It is maintainable, is easy, and reduces runtime and errors. Testing of application is it can be easily scalable. So here you this is just a common diagram, but here we might see that this is like a Flux diagram in reality. We have we have a few views which might provide some action to action creators. They are dispatching. Then this dispatcher acts as a central, working with the data, which was with every actions to store via store the callback. Not like this. So dispatchers acts as a central hub, as I mentioned before, right? So it sends every actions to all stores, then sends all actions to the stores via callbacks that that have registered with it, right? So the stores it updates themselves, responds to an actions, and send the result to controller view, and views provide changing the data, and the data flow is the chain is closed. We are going to some actions, and once again. So we should remember some important things. So maybe I forgot something actually. Yeah, so let's talk just a little bit more closer about dispatchers. So just mentioned more information about dispatcher. It is a central hub for the React Flux application and manages all data flow of our Flux application. It is a registry of callbacks into the stores. It has no real intelligence of its own and simply acts as a mechanism for distributing the actions to the store. all stores register itself and provides a callback. It is a place which handle all events that modify the store. When the action creator provides a new actions to a dispatcher, all stores receive the actions via the callback in the registry. Repeating, but it's okay. So the dispatcher's API has 5 methods. They is register. It is used to register a store action handle callback. Unregister, it is unused to unregistered a store's callback. Wait for, it is used to wait for the special callback to run first. Dispatch, it is used to dispatch an actions, and in dispatching, it is used for checking if the dispatcher is currently dispatching an action. So stores primarily contains the application state and logic. It is similar to the model in a traditional model view controller. It is used for maintaining a particular state within the application, updates themselves in response to an action, and emit the change event to alter the controller view. Views, it's also called as a controller views. It is located at the top of the chain to store the logic, to generate actions and receive new data from the store. It is a React component, listen to changes event and receiving the data from the stores and re-render the application. Actions, when dispatcher method allows us to trigger a dispatch to the store and include a payload of data, which we call an action. It is an action creator or helper method that pass the data to the dispatcher. So, and advantages of the flags. It is an unidirectional data flow model, which is easy to understand. It is open source and more of design patterns. What are formal frameworks like model view controller architecture. And the data, the Flux application is easier to maintain. And the Flux application parts are decoupled. So, seems like I mentioned all advantages, important things in Flux, and we can move to Redux. So, one more things about React Redux. It's React Redux I've opened. Incorrect notes from my side. Okay, so Redux. Need to open something new. Where is my notes? Okay, Redux is an open source JavaScript library used to manage application state. React uses Redux for building the user interface. It was first introduced by Dan Abramov and Andrew Clark in 2015. In 2015. React Redux is official React built-in for Redux. It allows React component to read data from the Redux store and dispatch actions to the store to update data. Redux helps application to scale by providing a sensible way to manage state thought and to manage state through a unidirectional data flow model. React Redux is conceptual simple. It is subscribed the Redux store, checks to see if the data which your component wants have changed, and render your components. This is just small introduction in React Redux 2. So, Redux can be described as three fundamental principles. The first single source of truth. The global state of your application is stored in an object tree within a single store. This makes it easy to create universal application as the state from your server can be realized and hydrated into the client with no extra coding effort. A single state tree also makes it easier to debug or inspect an application. It also enables you to persist your application's state in development for a faster development cycle. Some functionality which has been traditionally difficult to implement can suddenly become trivial to implement if all of your state is stored in single tree. Then the second principle, this is a state is read-only. So the only way to change the state is to emit an action, an object describing what happened. This ensures that neither the views nor the network callbacks will ever write directly to the state. Instead, they express an intent to transform the state. Because all changes are centralized and happened one by one in strict order. There are no subtable raise condition to watch out for. As actions are just plain objects, they can be locked, serialized, stored, and later replayed for debugging or testing purposes. And the last principle, changes are made with pure functions. To specify how the state tree is transformed by action, you write pure reducers. Reducers are just pure function that takes the previous state and actions and returns a new state. Remember to return new state objects instead of mutating the previous state. You can start with a single reducer, and as your application will grow, split it off into smaller reducers that manage specific part of the state tree. Because reducers are just functions, you can control the order in which they can call, pass additional data, or even make reusable reducer for common tasks such as pagination. So, Redux data flow. So, how to start? So, before we dive into some Acts code or let's talk about some terms and concepts you need to know to use Redux. Let's start by you know, maybe we might try to try to understand how state management is going in Redux. So let's imagine that we have some counter component, and we are tracking a number in component state and increment the number when button is clicked. It is self-contained and with the following parts. It's self-contained with the following parts, right? So actually we need a state for this. We need a view and some actions. The state will be the source of truth that drives our application. Then the view, you know, like here, a declarative description of the UI based on the current state. An action, the event that occur in application based on our input and trigger updates in a state. This is a small example of one-way data flow. State describes the condition of the application. So just, you know, like we have some action, we have a view, and we have a state here. Let's think that this is, it's not a state, but state is a part of process or inside of store, right? So just try to imagine that it's more simpler. So the state describes the condition of the application and the specific point in time. The UI is rendered based on the state. When something happens, such as user clicking on the button, yeah, so we have 1 and we might see 10 or more dollars plus in, right? So the state is updated based on that occurred. The UI is rendered based to the new state. So, however, the simplicity can break down when we have multiple components that needs to store and use the same state, especially if those components are located in different parts of the application. Sometimes this can be solved by lifting state up to pattern components, but that doesn't always help. One way to solve this is to extract the share state from the component and put it into the centralization, like centralized location outside the component tree. With this, our component tree becomes a bigger view, and any component can access the state or trigger actions no matter where they are in a tree. By defining and separating the concept involved in state management and enforcing rules that maintain independence between views and states, we give our code more structured and maintainability. This is basic idea behind Redux, a simple centralization place to contain the global state in your application and specify patterns to follow when updating that state to make the code predictable. So let's talk about Redux store. So should I? Yeah, that's all about previous slide. So creating store, right? So we should start maybe not like this. Which command helps you to install Redux into your application? Maybe from this is the best question, right?
Let's talk as is. It's
It's
high on such high level understanding.
okay.
It's okay because it's hard to deep dive in details at
Okay.
once.
Okay. Thanks. Then, as it is, right? Creating a store. The React store brings together the state, actions, and the reducer that makes your make up your application. The store has several responsibilities: hold the current application state inside, allows access to the current state via store get state. Yes, from this function. Then allow state to be updated via dispatch action, and register listener callback via subscribe. Unless understanding of listeners via handless understanding. Sorry, not understanding, unregistering of listeners via unsubscribe function returning by subscribe listener. We will see it in this example. It's important to know that you only have a single store in a Redux application. When you want to split your data handling logic, you'll use Redux composition and create multiple reducers that can be combined together instead of creating separate stores. So in this example, we can see how we can create our store. Every Redux store has a simple root reducer function. We create a root reducer. So we might combine our stores and we might create single stores. I think I must say like this. The Redux core library has a create store IP that will create the store. Add a new, if you try to create your store, just add a new file called like store.js and import create store and the root reducer. Then call create store and pass in the root reducer. Root reducer usually puts here, but maybe, yeah, so create store has that holds the complete state tree of your application. As I mentioned, this is a single store in our application. The arguments which contains it's a reducer. This is a function, a reducing function that returns the next state tree, gives the current state tree and an actions to handle. So initial state you might optionally specify to hydrate the state from the server in universal application or to restore a previous serialized your session. If you produced your reducer with combined reducers, we will take a look at this a bit later. This must be a plain object just with the same shape as the keys passed to it. Otherwise, you just might put a free to. So otherwise, you might put anything that your reducer can understand. And about an enhancer, this is a function the store, which is store enhancer, you might optionally specify it to enhance the store with the third party capabilities such as middleware, time travel, persistence, and many other. The only store enhancer that ships with Redux is apply middleware. And what is returns, right? So an object that returns a store, this is an object that holds the complete state of your application. The only way to change its state is by dispatching actions. You may also subscribe to the changes to its state to update the UI. So, like here. Here we see that we create in our store. We have a handler here. So we might subscribe to in order to watching some events or change in state which is happening in our application, and not subscribe. We're subscribing, but this automatically, right, Mikhail, as I understand this. And if we don't need any watching to some changes, we just unsubscribe from this using this syntaxes, store, subscribe, here put in handler function, and
I may say that if we use pure Redux, we do such thing. But for example, when we implement it in React project, we use library React Redux, and it export functions which, for example, hooks, as we say, you select it do automatically.
Yeah, we will talk about React Redux in just a bit later. Here will be more simpler.
But we should know that there is a subscribe function which trigger, which is something like observer, and with it look for changes and re-render, set signal, send a signal to re-render.
Thank you, Mikhail. So about here, I'm just thinking.
It's about a reducer. It's a pure function about what we were talking a bit late previously, recently. So it's example, small but a good example to understand how it changed. We have a action. It's convenient. It's convenience that it's have a type and payload. You may name this props as you wish, but it's good practice, best practice set that you use type for type and payload for data to which we want to save in state. And you may see type increment, decrement, and change count. It's three types, three parts of this reduce function.
Yeah.
We trigger a small change.
Yes, yes. So Mikhail almost described this example. So here we have a reducer one again. We have a state and some actions. Usually from the action we have types, which is important, and many and some other options. And here in this example we have a switch in this reducer, which is returning depending of type some increment, decrement for our state, changing some state. And here we are creating store. Into the store we put our reducer and dispatch this store. And if we try to see which is happening with our state, here it will be 2, 3, 1, so and so on. This is a working example. I will actually, I might provide you also a link if you need to how to create step by step, but this is almost a full example. Just need to install the Redux in your computer and you might try this example by yourself. Then I many times talked about combining reducers, and so usually if we're talking about Redux, the main tips which I by myself mentioned a few times: don't create more than one store in the application. Instead, use combine reducer to create a single root reducer out of many. And give me a second. So here in this example, we see that we have one reducer, user reducer, which is he doesn't do nothing. The mailer reducer also doesn't do nothing, just returning the state. And we have a root reducer, which is combine reducers by user and in a combine these two reducers, user reducer and mail reducer. Then we create a store with our combined reducer. The key point here that he returns combined state, right, Mikhail, with data from our reducer, which we implement in these combining reducers. So yeah, that's how combined reducer is working usually. About nesting and nested reducers. Nested state isn't recommended practice, right, Mikhail? As I remember,
yes,
many articles.
Yes, it's harder to maintain such tree of reducers, and one level it's enough. If you need more than one, just see. Just in many cases, you need to refactor or rethink the solution. Just make some changes in your architecture, and so it's you can do it, but it's not best practice.
Yeah,
it's not a good.
right,
It's not not best. It's not a good practice. It's a bad practice.
Yeah, so reducer, like reducer any function with a signature state in action, right? Which we hear in this simple example, which is creating new state. It means that any function that could be used as argument to array reduce. Then the root reducer is the reducer function that is actually passed at the first argument to create store. This is only part of the reducer logic that must have the state action use state signature. Since reducer isn't nothing else but a function, we don't have to use it for create store. Actually, like so it might be not a good it's about actions, but yeah, so our no, so we don't have actually here some examples, but yes, so if we have many reducers which is involved, but only one is used to which we implemented, but only one might be used as a root reducer, so we might consider those reducers as separate features. But what if we want, but in this case, if we want the same nesting by the so if we would like to make it more complicated, it will be, you know, like difficult. It will as I understand, so maybe in a shorter way, better to say here, just if you try to nest it your reducers, it's just create more heavier structure and maintainable structure, more heavy maintainable structure, right? That's why not pretty recommended. Yes. So about actions. So actions are plain JavaScript object that have a type field. As mentioned earlier, we can think of an actions as an event that described something that happened in the application. In the same way that we describe the state structure based on the application's requirement, we should also be able to come up with a list of some of the actions that describe what's happening. So add here we so we here see here our action with the type add to do and other optional keys and other options, which is payload, call mom, error false, and meta where we find more, which is object here. So as I mentioned, so give me a second. So as I mentioned before, in the same way, for example, if we designed the state structure based on our application environments, we should also be able to come up with a list of some actions, and they are like add a new to-do entry based to the text the user entered, toggle the compiled status of a to-dos. This is like, you know, let's imagine that we have a to-do list application. That's why we're talking about it. So what should do our application, right? Add some entry based, toggle the component state, select a color category for a to-do. For example, if we marked as done for some to-do, we might change the color, right? Delete to-do, create all components to-do, choose a different completed filter value, add a new color filter, remove the color filter, and so on, so on. This we normally put any extra data needed to describe what's happening into the action payload. field. This could be a number, string, or an object with multiple fields inside. Like in our example, we put into the type here some which is this type of to-do action, and according to this type, the Redux store doesn't care what the actual text in type field. However, our own code will look at type to see if an updated is needed. Also, you will frequently look at action type strings in the Redux Developer Tools extension while debugging to see what's going on with the application. So try to choose action type that are readable and clearly describe what's happening. It will be much easier to understand what's when. It might be better to understand what's happening or which action is so using this approach, we might easier understand which happening in our application. So this is like one example of to do. So this is example of one action from our needs, which is called add to do, and we put in here call mom. This is like one of the checklist, right? So this is like an additional fragment of data, but that's why it's going to payload field. We could have a split, not like this. What else here? So if, as I mentioned before, we might mark, for example, let's remember that, for example, we might add options like marked the field completed or not, or just changing color based on some logic, right? So we might add such we might add like some few additional actions like removed or completed, right? We might create different type of actions, put their type. Do we have here? No. So we might just creating some action marked as toggled completed. Payroll here marked as done, and that will be another actions. So actions should contain the smallest amount of information needed to describe what's happening, and then we are action. Let's take a look at this example. This is like action creator. Here we have a button which is by clicking on this button we might add to do, right? We dispatch this. We have a function which is called add to do. We're providing here some new action item and returning an object. It's returning our action with type and data which we provided to the new action item. So we dispatching this function and to unclick that's how we can add our action to the application. So right now let me see, we had the same Redux data flow. Okay. Side effect. So here, basically, in Redux application, we have 3 common approaches to side effect. So what is a side effect? The naturally Redux flow is this. Some action is dispatched, and as a consequence, some state is changed. If all our Redux application could do was just to change state as the user played with it, would your application will be particularly useful? Probably not, right? So most applications need to reach out to the outside world to be useful whenever, by talking to the server, accessing local storages, recording analytics event, or something else internally. That process is calling into the real world is what side effects are. They are a way of bringing the pure Redux world with the outside world. Common feature of side effects, just briefly. Some side effects can happen in response to Redux application, for example, to Redux actions, sorry. For example, when a user click save, you might want to fire off an Ajax request. Side effect might dispatch Redux actions, like when the save processes finishes successfully, you might want to dispatch save success, or when it failed, you might dispatch save failed. They also might do dispatch anything. Some side effect doesn't need to dispatch anything. If you are doing analytics tracking based on Redux actions, you would track things in response to Redux actions, but you will not dispatch anything. So these approaches, this is 3 main approaches, and so let me finish about side effect. These few approaches, they have some differences, pluses and minuses. No, it's not approaches, actually. This is like common features about side effect, and we have a few approaches, right, which might remove some which might handle this side effect, right? Which is they are inside action creators. It's pretty. So the first approaches inside action creators. They have this is like so what is it inside? It's pretty bare bones, but often it's just enough. You make a smart action creator which perform you side effect and might dispatch as action multiple times. This approach is really simple, no new concept, no mental overhead, but there are a few minuses, and one of them, this is harder to test, can get mess if certain actions involve several side effects and few others, then we might so have some code on the side response to user actions. So actions creators are still pure, but you now have some pieces of code that that can listen for a specific actions. So maybe approaches. Let me. I'm not sure. Just this is really good. So we. I just wanted you to show, a few examples. A few examples, right? So Redux. Redux side effects approaches. Yeah, I think it might be, it will be a bit difficult. So inside action creators, you just dispatch, as I mentioned, right? So we might dispatch, you might create smart actions creator, which perform your side effect and dispatch an actions multiple times, right? So also the second approaches have some code on site response to user actions. The proofs of one more. So you might do something with your so let me just how to rephrase it. Michael, maybe you can help me with more valuable examples, because seems like my thoughts cannot be super good at this. But that's just wanted to say that we have some approaches and we might solve them. And depending on approaches which we choose, we have some pluses and minuses, right? So, and maybe you might have a good example of side effect approaches. That's just my examples which I found actually.
I think it will be interesting when students with mentors will take some steps, practical steps, and after that it will be more understandable and interesting in mentors within mentor session.
Okay, then.
Anyway, it's hard
to
theoretically talk about this stuff. So I think we should move on. And mentors should ask mentors to.
Okay. Then I will provide you a few links to the. Oh, I didn't put a presentation. Okay, just later a bit I will add and provide you a few links, especially to this article too. Maybe you might try to implement this and try to talk about side effects approaches with your mentors then. About middleware. So give me a think about it. So if we, in our application, try to use some libraries like Express and maybe some other, we might familiar with. So if someone of you used some like Express libraries, maybe you might heard about middleware, such concept of middleware as a middleware. In this framework, in these frameworks, a middleware is some code you can put between the framework receiving a request. I'm talking about Express. Express, yes. In Express, middleware is some code that we can put between the framework's receiving request and the framework's generation, which is generating a response. For example, middleware in Express might add a course, headers, you know, in such way we might get some information definitely if we put some course headers, right? But Redux middleware solve different problems than Express, which as I mentioned before, but in conceptually similar way. It provides a third-party extension point between dispatching an action and the moment it reaches the reducer. People use Redux middleware for logging, creation, reporting, taking to an asynchronously API, routing, and many more. So while middleware can be used for a variety of things, including asynchronously API calls, it's really important that you understand where it comes from. We will firstly talk maybe you know, so yeah, maybe it's enough for about middleware. Mikhail, maybe I should something add, because, you know, usually we have a few problems, which is problem logins, and we might try to solve this login in many different ways.
No, I think it's enough.
Yeah,
we can say that it's something that reduces this pure function, but if we want to make some pure synchronous function is a reducer. And when we need some asynchronous logic, or we need some side effects, we should use middleware.
Yeah. I will just, if I try to develop these things, I might just, you know, make heavy this topic for understanding right now. Not good.
It's let's look at these slides as is. We can say this is this is a pattern which we use and why we use, but deep dive is a next step, I think.
Okay.
We need to see a simple picture of this. It will be better, I think.
Simple, yeah.
As it shows.
Yeah. Okay, here in middleware examples, login middleware, right? So let me think. So actually, we might, we've talked about things like we might, let's say, catching some errors or providing some information in which state we are in our application, what was done, or something like this. For this purpose, we are using login usually, and we might log in manually. Actually, but like just a console log. That's all. Like here, right? But in this, yeah. So here in so here in this middleware, log middleware, we have some actions. We have a type of action. We have some data for this action, and we might group by this type, right? And maybe, yeah. So depending, we might group this. We might group this these actions by type, and provide the data about what's happening in this group right now. That's how. That's what is written in this example. Maybe it will be good to see any screens, but no, unfortunately, we don't have here.
Let's talk about some piece of code, some piece of logic we implement and trigger next middleware. It's a chain of middlewares. We can put in the as a chain, and we can with no breaking the main data flow, we can put some for example, this login function, and for example, we want to save some data, and also want to log this action. We just put log middleware, and as it say, it's between trigger and state. Let's this to understand what we want to say. It's a middleware firstly, and as it shows before, we have a action, and during this action is happening, we can make additional logic. This additional logic we put in the middleware. So let's just think about like this and move on. And it's also should be demonstrated during practical work with mentors, I think.
Yeah, so here just, the example of synchronously middleware and asynchronous middleware login. So how to connect middleware? We see here our login. We see that our async middleware. And we here see that when we create store, we put in here our reducer and providing middleware with our login function and Tonic middleware function. So about Compose. Compose. So composes function from. So composes. This is a function. Not like this. This is functional programming utility, and is includes in React as a for a convenience.
Let's say it's just a small utility function method utility, which help us to combine multiple middlewares, and that's all. And
okay. It will be easier. So just mentioned about arguments. Argument, this is a function to compose. So you always, this is functions, right? Which is in this example to combine our middleware utility, right?
Yes.
Okay, so and then we are going to React Redux. Yes, so here, let me see what's a quick reminder for myself. Okay. I just hope my computer is in low charger. Okay. React Redux. What I should mention here. So this is like give me a moment. I've just mentioned about it a little bit before. This is React Redux is a official UI bindings for React applications. It's keep up to date with any APIs changes to ensure that our React component behaves as expected. It encourages good React architecture, and it implements many performance optimization internally, which allows to compose re-render only when is actually needs. React Redux architecture. So React Redux library needs us in order to include Redux to our React application. Here, do we have here some? Okay, this is about quick reminder about installation. React Redux installation, just providing us a comment in PM install Redux, React Redux. You just easily to find this comment in official website. About the about architecture, I might say a few words. We just don't have here any example of the architecture. It's maybe not so important, but what I would like to say that here we have a like give me a second. Everything is not, maybe it's not a good example. I just don't want to confuse you, but as we have a few, three at least, as I know, main components. This is a store. This is action and reducer. I just mentioned that. I just would like to mention that a store is a place where an entire state of our application lists. It's managed the state of the application and has a dispatcher actions functions. it likes, it's like a brain for our main Redux part. Action is sent or dispatched from the view, which is payloads that can be read by reducers, and reducers is read by payloads from the actions, and the updates the store via the same via the state accordingly. So, and here in this what else? About installation. React Redux requires React, which is version 16.8.3 or latest, and yes, and what else? We have a few comments if we would like to. Also, there is an additional comment if you would like create your React application with Redux. So as you remember, we using command npx create React application. Then we put a name application. So for example, my application, right? Or just my new project. And you just add you might add after these three common words additional flag with Redux. So template Redux or template Redux TypeScript for TypeScript. And in and also if you don't want to, if you developed your application using Redux, using React without Redux, you might add just Redux into your application. It's available too. That's what I would like to say. And React Redux includes provider component, which makes a Redux store available to the rest of your application. Then React React Redux Connect. The connect function connects a React component to a Redux store. It provides its connected component with the pieces of the data it needs from the store and the functions it can use to dispatch actions to the store. It doesn't modify a component classes passed to it. Instead, it returns a new connected component class that wraps the component you passed in. The connected has a few parameters, except the map state to properties. This is a function. If this is a function has two arguments. This is state and own properties. Also, what I should mention, the result of the map state to props must be a plain object, which will be merged into the wrapped component's properties. If you don't want to yeah, maybe that's enough about this. Then map dispatch to properties. So map so this is this should be an object, or this might be a function, which is just dispatch provide dispatcher. By default, it means and some own properties. So if you define a map dispatch to properties as a function, it will be called with a maximum of 2 parameters. That's what you need to know. And if yes, so this is a second parameter. Then merge properties. Returning about, so I should mention about what map dispatch to props should return, right? Is the map dispatch to properties function unexpected to return an object. Each field of the object should be function, colon, which is expected to dispatch an action to the store. So that let's go to the merge properties. Merge properties, this is a function, defines how the final properties for your own wrapped component are determined. If you do not provide merge properties, your wrapped component received some own properties, the object, the set of objects of own properties, state properties, and dispatch properties by default. The returns value of merged properties is referred to as merged properties. Merged properties, and the field will be used as the properties for the wrapped component. And options, this is an object with a few, with a few object which have few keys, such as context, are state equal, and in common words, object which have context and some details about properties, such as are state equal, are own properties equal, merged properties, state properties, so forwarded refs also. So connect, what is connect returns? The returns of connect is, I've mentioned it, right? So once again, the return of connects is a wrapped function that takes your component and returns a wrapped component with the additional properties it injects. In most cases, the wrapped function will be called right away without being saved in temporary variables like and you just my export, like this. Inject. This is about this. This is like about usages, and this is inject just dispatch and don't listen to store example. And here we have an example of how to inject all action creators without subscribing to the store. So connect our dispatches and to-dos. This is just a simple example, and maybe your mentors will provide you. Why I can't? It's really interesting. So this is just a simple example how you can use connect. Maybe you can talk about them with your mentors. And what I would like to say here, that about this is just this here is an example. Maybe I find something about React Redux tutorial and provide you a link, but that's most important things in React Redux. How to know it's to know that provider allows you to include your Redux into your React application, and the most important, this is a connect connect function, which is connecting your React component to Redux store, and a few methods how you can work with components in Redux with it. Just simple examples. That's all for today. Actually, I tried to find the tutorial how to create such components, and you might try to work with it by your own and discuss it with your mentors. Okay. It's just better to actually for small projects. Actually, as I know, for small projects, it's not good to use Redux because, you know, he needs you in case if you need to use if you need to have more complicated stores in your application. So in smallest projects, you just don't need this. Mikhail, maybe from
you're right. In small project, the efforts you should make to set up and maintain Redux store, doesn't worth the outcome. Yeah. But when you're learning, it's good to practice on small project, no matter how it's look like.
Okay, so I'm stopping the recording.